Hi there, folks. Today we're looking at box plots and outliers. And a box plot you might have remembered as a box and whisker plot. We just dropped the whiskers. It's still the same thing. We just call them box plots. And then we're going to officially learn how to calculate whether or not something is an outlier. So far, we've just been suspicious of values, and we've said things like, there appears to be an outlier. This might be an outlier. But now we're going to make a determination over whether or not mathematically it actually is an outlier. Okay. So to do a box plot, the first thing we need is the quartiles. And we'll talk about this thing called this 5-value summary. The 5-value summary is what makes the box plot, okay? And the things that are involved here are the quartiles, which include the median, all right? The quartiles are the values that divide this thing into 4 equal parts, okay? And when we think about the median is the spot on the data that divides it into 2 equal parts. So if we kind of take each of those parts and do the median again of the first half and the second half, those are going to be our first and third quartiles, and those will break the data into 4 equal pieces, okay? The interquartile range, I'll refer to that in abbreviation form as the IQR. So the interquartile range, that's just the range of the quartiles, this difference between the biggest quartile and the smallest quartile. So it's always the third quartile minus the first quartile, okay? So when we subtract those, that gives us the range of the quartiles. And again, it's just another measure of spread, how spread out the data is. That's what range is. That's also what the interquartile range is, okay? So it's just different measurements of spread. The reason we tend to trust the interquartile range over the overall range of the data is because the overall range of the data might be affected by outliers, okay? The interquartile range would not be typically affected by outliers, okay? It would be impossible for it to be affected by outliers, okay? And so that's the idea. This is maybe a better measurement of spread when we're comparing how spread out data sets are, okay? And then the box plot, again, we're using this summary of data. We call it the 5-value summary. And because it includes 5 values, it's the maximum, the minimum, and the quartiles 1 through 3, okay? The maximum and the minimum, these are always plotted as points, okay? So these are points, and these are where our kind of whiskers go on this thing. Those are these pieces on the end will go to the maximum and the minimum, okay? And then the quartiles, that's the kind of our box piece of these things. These are graphed as like line segments. And again, those are the pieces in the middle that make this box. The two ends of the box are the first quartile and the third quartile. The middle of the box is that median, which is the second quartile, okay? For example, I'm going to make a box plot of each of the data sets. And so the first thing we need to do is we need to identify all the different values here. And I'm going to start with the quartiles. And when you start with the quartiles here, well, I guess I can start with the maximum, minimum as well. But I'm going to do all of these things. I'm going to do maximum, minimum. So the minimum, the first quartile, the second quartile, which again is the median, same thing as the median, the third quartile, and the maximum. Those are the 5 values I want to hunt down, okay? And so, yeah, again, we can start with the maximum, the minimum, or we can start with the quartiles. We'll start with the quartiles here and just say, okay, the second quartile is the median. So I just have to count to the center of this data. And if I kind of count to the center of this data, I'm going to find out that this value right here, the 46, is right smack dab in the middle, okay? I have the same number of data values on this side as I do on this side, okay, counting towards that center, all right? So that is my second quartile. That's Q2. That's the median. And I'm just going to write that down here. So that's 46. Sorry, I was going in green. I keep these things in green, I guess, down here. And then when I look at the first half of the data now, if I only looked at these data values, okay, and ignore everything else, and I count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data values, I just pretend those are my data values, and I'm going to find the center of that. And if I do my little n plus 1 divided by 2 formula, so 11 plus 1 divided by 2, I get 6. So it's telling me the 6th data value, 1, 2, 3, 4, 5, 6, is this one right here. That is my first quartile, okay? And so that one is my first quartile. So that's Q1. And really, it's the median of the first half of the data. So that's the first quartile. Messing up my color scheme here, okay? And then the third quartile, do the same thing, but I do that for the second half of the data. If I do that for the second half of the data, I'm going to find it's this one. is Q3. Again, I count up those data values. There's 11 in the second half of the data, so I'll go to the sixth one. 1, 2, 3, 4, 5, 6. Okay. And so that's my third quartile. 51. And then the maximum and the minimum are just like the biggest value and the smallest value that's listed here. And so on this one, the minimum value is right here. It's the smallest value. And the maximum value is right here. It's the biggest value. Okay. So minimum is 40. Maximum is 61. Okay, so that's my 5 value summary. I'm going to do the same thing over here for the, that was the height of middle school boys. This is going to be the height of the middle school girls. And really, when I do this, it should go a lot quicker this time. I don't know if you noticed, but these data values are the same size and they're structured the same way. So just positionally, I can see that this one's in the same spot. So that's my second quartile. Because again, I'm going to go through the entire exact same counting scheme right here. That's going to be my first quartile. Again, it's halfway through the first half of the data. And then this one is going to be my third quartile. It's in the same position. It's halfway through the second half of the data. Okay. And once again, my maximums and minimums here. This is my minimum. This is my maximum. Okay. But again, I find the median by counting to the center of the data, and then I find the first quartile by counting to the center of the first half of the data. I find the third quartile by counting to the center of the second half of the data, okay? So it's like we're doing the median over and over and over again when we calculate those quartiles. So should be fairly simple, okay? So here the minimum was 40, first quartile was 44, this was 51, 56, and 60. And so now when I plot this thing, I already drew the number line down here just to save myself a little time as I'm making this video. But I want to make sure the number line is consistent. I don't want to jump around. Notice I've scaled this thing by 2s, and I'm just letting it kind of continue to count by 2s. Okay, I don't want to. This little thing popped up. I don't know what that is. I don't want to jump around when I'm creating this number line. It has to be consistent. It has to be a nice, neat number line like this, okay? And so now what we're going to do is I'm going to plot both of these on the same number line. So I'm going to do the boys up top, and then I'll do the girls down here. And I'm just going to plot this this box plot. So like the boys had a minimum of 40. It's right here. And the first quartile was 42. And again, when I do the 42, I draw it as like a line segment. The 46 is the median, so I just go above where the 46 is and draw a line. 51 is halfway in between these two. And then 61 is the maximum. I connect these with a box. I connect these with those whiskers. And that's my box plot. It kind of shows me how spread out the data is. I can see that the data is more spread out the top than it is at the bottom. Okay, so there's more drastic differences in the height. And then I have to do the same thing with the girls here. So let's see, their minimum was 40. Their first quartile was a 44. And then a 51. And then a 56. And a 69. And that is the dot over here. So again, I make a box using those quartiles. I connect the maximum and minimum with these kind of whisker things, okay? And really, when we look at that, we can kind of see that the boys' data is clearly more consistent. Their heights are more consistent in middle school, and the girls are more varied. And that makes sense, you know, because girls typically hit growth spurts earlier than boys. So they would have a much greater discrepancy in terms of the tallest versus the shortest. So yeah, they're spread out because they have a lot more people that are hitting those massive growth spurts. The boys probably going to be closer, like that's what the boys' data would look like in high school, okay, when they're hitting their massive growth spurts, okay? But it gives us a very easy side-by-side comparison of these things by putting the box plots on the same number line, okay? So let's talk about outliers. The outlier we're going to use, the outlier rule that we're going to use is this 1.5 rule. And there are other rules that we can use for outliers, but this is the one that we're going to go with. Basically, a data value is considered an outlier if it's more than the third quartile by 1.5 times the interquartile range, or it's less than the first quartile by 1.5 the interquartile range. And that seems complicated. But when we look at it in terms of a formula, we just take the first quartile minus 1.5 the interquartile range, and that basically gives me the lowest acceptable data value, okay? And then we do quartile 3 plus 1.5 the interquartile range, and that gives me basically the highest acceptable data value. And so it's this idea of 1.5 the interquartile range tells me how far I'm allowed to go away from that box before we're considered an outlier, okay? And so when we think about the box plot, that box represents the interquartiles, it represents the quartiles. Well, the 1.5 times the interquartile range is telling me how far in each direction from that box I can go, which is why we subtract on one end and add on the other end in order to get this range of acceptable values, okay? For example, I'm going to find the 5-value summary, identify any outliers, and then I'm going to graph the thing, okay? So again, let's do the minimum, first quartile, second quartile, third quartile, maximum. Okay, that's my 5-value summary that I'm going to do. And so the minimum this time is the 45. The maximum this time is the 128. And again, we can see those right here. It's these are already listed in order, so I can see the minimum here and I can see the maximum here. The second quartile here, when I look at this thing, again, I would have to look at how many data values there are. Looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 of them this time, okay? So if I do that rule of n plus 1 divided by 2, it would be 13. So if I go to the 13th data value, it's this one right here, which is Steel Vengeance. So that is my second quartile. That's my median value, okay, is the 74. And so now if I look at the first half of the data, there's 12 data values. So again, if I do my n plus 1 divided by 2, at 12 data values, that's going to be that's going to mean that the median of that first half is at the 6.5th data value, which is actually halfway in between Iron Rattler and Velocicoaster. And so if I'm in between those two, halfway in between 70 and 70 is also a 70, okay? And so that's my first quartile. My third quartile, again, I do the same thing. And if we have the same number of data values, it's going to be the 6.5th data value again. So again, that's going to be halfway in between the Diamondback and the Phantom's Revenge. And halfway between the 80 and the 85 is going to be an 82.5. And so that's my third quartile. And so now calculating the calculating the outliers requires the interquartile range. And so the interquartile range is just the range of the quartiles, which is just the third quartile minus the first quartile. And when I do that, I find out that the interquartile range is 12.5, okay? So now to find the acceptable range of the data values, this is where I use this formula. And I'm going to do Q1 minus 1.5, the interquartile range. 2, that's going to be Q3 plus 1.5, the interquartile range. And again, this is going to end up being a job for my calculator. This one is 70 minus 1.5 times the 12.5. And I'm going to punch that into my calculator exactly the way it's written. Order of operations is going to cause the multiplication to happen first and then subtraction, like that's the way it should be. This one's 82.5 plus 1.5 times the 12.5. And so if I grab a calculator and punch this in, when I punch this into the calculator, this one gives me a 51.25. This one gives me a 101.25. And so essentially it's saying that acceptable data, the acceptable data range for this thing would be 51.25 to 101.25, which means anything that's within that range is an acceptable data value, is data that makes sense, that is grouped close enough together that it wouldn't be considered an outlier. Anything that's outside of that range would now be considered an outlier. So as I look at my data, I'm looking to see if there are any values that don't fit within the range of 51.25 to 101.25. And there's actually two of them over here. I can see right here, this very first value, the 45. 45 does not fall between the 51.25 and the 101.25, which means that 45, that trailblazer, that's going to be considered an outlier. So that one has to be an outlier. Okay. See, the outlier rule tells me what the acceptable range of data values is. Anything that's outside of that is an outlier. And the other one that's an outlier right here, this very last one, the 128, also does not fall within the 51.25 to 101.25. So this one would also be an outlier. Okay. Notice everything else that's in here falls within that range. Like if I look at the next one up here at the top, 57. Yeah, that's in between the 51.25 and the 101.25. Down here at the bottom, the 95. Yeah, that falls within that acceptable range. Okay. So now we've identified the outliers. So the first value and the last value are outliers. And here's how that affects the box plot when we graph it. So once again, I've already drawn the number line here. And that's just to save a little bit of time. Okay. And so for this one, I'm still going to start by plotting the maximum and the minimum and that kind of stuff. So like on this one, the minimum was the 45, which is right around here. And the maximum was the 128, which is way up here somewhere, right around here. And then the quartiles, I have to go back and look. Let's see, we've got 70 right here. That's this one. 74. It's going to be right around in here. 82.5. It's going to be right around here somewhere. Whoops. And so here's what we don't want to do. We don't want to do this, okay? I can make that box, but I don't want to connect these, okay? I want to show that those are outliers. And so to show that those are outliers, I want to leave those points separated from the rest of the data. So in order to draw the whiskers, I kind of have to go to the next value, okay? So instead of using this minimum value to connect my whisker and this maximum value, since those were outliers, I go to the next available data value. So like on the bottom end, the next available data value is this one. It's the 57. And on the top end, the next available data value is this one. It's the 95. Okay. So on my box plot, I'm actually going to plot those almost like my maximum and minimum values. So the 57, which is right here, and the 95, which is right here. And those are the ones that I'm going to connect with these whiskers. And the reason I do that is it shows me how actually condensed this data is. Like if I were to draw that all the way out to the outlier, it looks like the data is really spread out on that top end, when in reality, it's not really that spread out. It's just that one point is way out of place. And so to display outliers on here, I want to make sure that they are listed there, shown there as separated from the rest of the data, because we've determined that they're far enough away that they're not within the acceptable range. We want to show that they are outside of the normal data values, okay? So we kind of plot them as separate points away from our box plot so that we get a better sense of how condensed the data is when we ignore those things, okay? So again, box plots use that 5-value summary, the maximum, minimum, the quartiles, which again, the quartiles is like finding the median and then finding the median of the first half, finding the median of the second half. So it's finding the median 3 times essentially. And then outliers, we do that interquartile range, which is third quartile minus the first quartile. And then we use that formula of 1.5 times the interquartile range. We subtract that from quartile 1. We add that to quartile 3, and that gives us our acceptable range of data values. Okay. Anything outside of that is an outlier. Okay.